Understanding the file systems. A hard drive can have multiple partitions on it, and in each partition there will be a file system. There might be hundreds of thousands of to millions of files contained within a partitions. So the file system tracks where every file is and how much space is available within the partition boundaries. We discussed sectors earlier in the hard drive and solid state drive section of this course, and they are the smallest units that are available to store data. The file system stores data based on clusters. Clusters are one or more sectors. So a cluster is the smallest allocation unit that file system can write to. So now there are many file systems available, and some are restricted to specific operating systems, unless the user enables drivers that will allow the operating system to read the file system. So we will look now at some of the common file system you may encounter. So the VFAT file system, file allocation table. So the file allocation table file system has been around since the early days of home computing. And it's one of the file systems that nearly all operating systems can read. So it's a de facto standard file system for removable devices. As the time has gone by, the VFAT file system has gone through numerous changes. So the first VFAT file system is the FAT12. So this is created in 77 and used 12 bits, hence the FAT30 designation, to address available clusters. So it used 12 bits to address available clusters. So, but this is limited. It used the only storage devices that could contain 4069 clusters. So it's rarely seen nowadays, but you might find it on a floppy disk. So then we have FAT16. This is created in 84, and FAT16 used 16-bit to address available clusters, so it had the same uses as the FAT12, as it could not be scaled to be used with larger capacity device. So it's not compatible. FAT6 and FAT12, it's not compatible with large capacity devices. And then we have VFAT. So this is introduced with the Windows 95 and at the virtual file allocation table. So it added the long file name LFN and additional timestamps here. So then lastly, we have FAT32. So the FAT32 uses the 28 bits to address available clusters, theoretically allowing for a maximum volume size of 2.2 terabytes. So Microsoft implemented restrictions that limited the file system size to 32 gigabyte with a maximum file size of 4 gigabyte. So it is still in use today and can be found on most removable devices. We will discuss FAT32 file system for a reminder of this lecture on the FAT file system. So the FAT file system here, actually let's make it a little right here. So the FAT file system is laid out in two areas, as you can see here, system area and data area. So the system area, actually let me write that down. Actually, I don't feel it. So system area. So system area is stores the volume boot data, boot record actually, boot record, and FAT tables. Here. Actually. So, but the data area here, this data area stores the root directory. directory and files. So as you can see here, we have boot record FAT1 and FAT2 is engaged with system area, and the root directory and files is engaged with data area. So these are the volume records and these are the root directory and files. So now let's get into the next topic in this lecture. So this is the boot record. So in the system area, we have the volume boot record, VBR. So we can find it in a logical sector LS0, which is the first sector within the partition binaries. Um, so the boot process here creates the VBR when the partition is formatted and contains information about the volume and boot code to continue the boot process for the operating system. If it is a primary partition, the VBR will consist of several sectors, typically sector 0, sector 1, and sector 2, with the backup in sector 6 and 7 and 8. The VBR and backups are stored in a reverse area, so which is typically 32 factors before the first file allocation table begins. So this is the VBR sector here. Now we will find these direct in this hex codes here. We can see a volume boot record, which helps to decipher the information so actually let me write that down here in the left side of this screenshot here. Here. Okay. So we have x00. This is the hex byte here. So in this hex here, we will find the jump instructions. Jump instructions for the system to continue booting. And x03 here, we will the UMID. This is the UMID which operating system was used to format the device. So this is the bytes per sector. Here, actually, let me open it. Bytes per sector. We also have 0E here. This is the reserve sectors. So this is actually in not the entire reserve sector. This is just shows the number of reserve sectors in our in our VBR here, and we have here x0 x actually x10, right? Yes, this is the x10. This is the number of FATs. Actually, in this case, it's usually 2. So we have x11. So this is the unused root entries. So there is a trick for that. So if you're using FAT32, this should be 0, because the root directory is in the data area, as we discussed earlier. So as you can see, root directory in the data area, which in this if you are using FAT32, in your case it will be 0 for you. So we have 13. So this is number of sectors. We have 15. This is the media descriptor. We have 16 here, and then we will have 18, 16. This is the number of sectors per FAT. Now if you are using FAT32, this should be 0 in your case here, and this is the number of sectors per track. Sectors per track. So this is the total sectors for the volume. We have x20 here. This is the logical sectors per FAT. And then we will have extended flags. So actually these are the pretty advanced topics in digital forensics here. We will continue these advanced topics in next lectures of our course. So next we will look at the file allocation table in next lecture here. Actually, end of this section of our course, there will be a practice test, which I'm sure you can do it. So I'm waiting you in next lecture.